We want to talk a little bit about roots and radicals. So I've got a bunch of expressions up here, and we want to figure out what those expressions are equal to. Okay, well, let's just start with x to the 1/2 squared. Okay. By the rules for exponents, you have a power of a power. So this is x to the 1/2 times 2, which is x to the 1, which is just x. What about x to the 1/4 to the 4th power? Now think that one through. Stop and think it through. Just pause the video and think it through. Okay, well, similar to the one above, we write this as x to the 1/4 times 4, which again is x to the 1, which is just x. What about 25 to the 1/2 squared? Well, we could do the exponents because we know that any number to the 1/2 squared is just that number itself, isn't it? Because since x to the 1/2 squared is equal to x, 25 is just an instance of x to the 1/2 squared with x equal 25, and that's going to equal 25. Now, you can also note that 25 to the 1/2 is the square root of 25, and that's, if you square that, then you get 25. Okay. So I could say or. Square root of 25, because the 1/2 power is the square root. That's 5 squared. And that's 25. 16 to the 1/3 cubed is, again, just 16, because if you multiply the exponents 1/3 times 3, you get 1, which is just 16 to the 1. Now we can verify this. What is 16 to the 1/3? Well, 16 to the 1/3 isn't something we can express as an integer. Okay, so this can get a little trickier. If we indicate, instead of 16 to the 1/3, we say that this is 2 times 8 to the 1/3 cubed. Well, we can do something with that. I haven't left myself enough room on the board to do it, so I'll put a little circle around it and we'll continue this after we run through most of the rest of these. Now let's say we have the equation x cubed equals 27. How do we solve that equation? Think about it, pause, see what you can do. Okay, well, x cubed to the 27th, there are several ways of solving this. We can just do it by inspection. I'll give you another method soon. What number cubed equals 27? Well, let's just take integers. Let's try 5. What's 5 cubed? 5 squared is 25. Multiply that by 5, you get 125. 5 cubed is 125. Yeah, what's 4 cubed? You know, 5 is too big. 5 cubed is bigger than 27. What's 4 cubed? Well, it's 4 times 4, which is 16. Multiply that by 4, you get 64. It's still too big. What's 3 cubed? Well, 3 cubed is 3 times 3, which is 9, multiplied by 3, which is 27. So x equals 3. Since 3 cubed equals 27. X squared equals 81. Well, what number do we square to get 81? You try different numbers, and hopefully you don't need a calculator to do this. You should certainly know the squares of all the numbers up through 10. And multiplication tables up through 10. You shouldn't need a calculator to do that, because if you need a calculator, you can't think about these things. You get the right answer, but you can't think about it. Okay? And if you don't know those multiplication tables, practice them. You can learn them when you're 8 years old. You can learn them now. In any case, we could square different numbers, okay? Let's say 5 squared is 25. Well, 5 is too low. 6 is probably too. Let's try 7. 7 squared, that's 49. That's too low. 8 squared is 64. 9 squared is 81. So I'll say this: 9 squared equals 81. So x equals 9. How about x to the 4th equals 81? Well, there are different ways to do this, but the simplest way is try numbers. Number can't be too big, because, if you square 9, you get 81. So you're not going to try to do the 4th power of 9, which would be 700. No, that'd be a 3rd power. But anyhow, so let's start small. What's 2 to the 4th? Well, you can work that out. Work it out on paper, in your head. Don't use a calculator. 2 to the 4th is 16. Okay. How about 3 to the 4th? Yeah, let's see. Work it out. See what you think. Is 3 to the 4th equal to 81? Well, yeah, it is. 3 times 3 is 9. 3 times 9 is 27. 3 times 27 is 81. Three to the 4th is 81, so x has to be 3. X to the 5th equals 32. Figure it out. Don't use buttons on your calculator. Put the calculator away and do a little bit of arithmetic in your head. If your head gets a little confused, which it might, doing the 5th power, write it out. Okay, you're going to discover that 2 to the 5th is 32. 2 times 2 is 4. Multiply that by 2, you get 8. Multiply that by 2, you get 16. Multiply that by 2, you get 32. Now, what's the square root of 36? Figure that out. What number you multiply by itself to get 36? You get 6. And of course, that's the same as 36 to the 1/2. As you raise 36 to the 1/2 to the 2nd power, you get 6 to the 2nd power, which is 36. Okay, what's the cube root of 64? Okay, well, that's a number you cube, you get 64. What do you cube to get 64? Well, the answer is 4. And that's, of course, equal to 64 to the 1/3. 4th root of 125. Let's try some numbers. Okay. 4th power of 2 is only 16. 4th power of 10 is 1,000. So it's not over 10. It's not as little as 2. What is it? Okay, well, hopefully you've paused and done it yourself instead of waiting for me to tell you. It's 5. And I just note that that's also equal to 125 to the 1/4. Now you can put this into your calculator, and you should know how to do that, because sometimes you need the 4th root of like 1,227. And that's not something you can do in your head. It's not something you can even write out exactly, because it's an irrational number. So it's good to be able to use the calculator to calculate things, but to understand what's going on, you got to be able to do it with simple numbers. Okay. Now, what's x to the 1/4 cubed? Okay. Well, we could write this as x to the 1/4 times 3, which is an x to the 3/4. And that's, of course, something that could go into your calculator if you had a value of x where you couldn't do anything with it. Okay. So x to the 3/4 means x to the 1/4 times 3, and x to the 1/4 times 3 is x to the 1/4 cubed. It's also x cubed to the 1/4. Since a power of a power multiplies the exponents, it doesn't matter which exponent goes here and which exponent goes here. If you do x cubed to the 1/4, you get x to the 3 times 1/4, which is just like x to the 1/4 times 3. Okay, what's x to the 1/5 squared? Well, that's x to the 1/5 times 2, which is x to the 2/5, or x squared to the 1/5. How about the cube root of x squared? Well, the cube root of a number is the 1/3 power. Okay, cube root is the 1/3 power, so this is x squared to the 1/3, which is x to the 2/3. Down here, fourth root is the 1/4 power. The 1/4 power of x to the 5th is, well, it's x to the 5th to the 1/4 equals x to the 4/5. And it would also be equal to the fourth root of x to the 5th. Forget what I said. Okay, it's x to the 4/5. Okay, say we have an equation, square root of x minus 2 equals 49. Okay, well, that means x minus 2 equals 49 squared. Which we can solve for x. Just square 49. What is that? 50 minus 2401. And add 2, you get 2403, I think. So you can try that. What about the cube root of x squared plus 3 equals 2? Well, if the cube root of something equals 2, then that something has to equal 2 cubed. That means x squared plus 3 equals 2 cubed. And 2 cubed is 8. Add 3 to 8. Sorry, subtract 3 from 8, you get 5. You get x squared equals 5. And x is the square root of 5, whatever that is. And that's something you would have to put in your calculator. Okay. What's the square, or the square root of 8? Now that's something you'd have to put into your calculator, but it can actually be simplified. This is the square root of 2 times 4. Which is the square root of 2 times the square root of 4, which is the square root of 2 times 2, which we'll usually write as 2 times the square root of 2. Usually the square root goes after the number. Okay, well, that's not a tangible answer, but that's a simpler form of the square root of 8. Because now all you got to do is take the square root of 2. Of course, with a calculator, it doesn't really matter, but you do have to understand simplification. Okay, how about the square root of 128? You should be pausing on these, okay? Especially now. Let's pause on this one and see what you think before I tell you the answer. Okay, well, I'm going to continue to tell you the answer. Hopefully you've thought about it Okay. I'm going to say the easiest way to do that might be to do the prime factorization. If I divide 128 by 2, I get 2 times 64. Well, at this point, I notice that 64 is the square of the number, so really we don't have to go as far as a prime factorization. It's the square root of 2 times the square root of 64. Square root of 64 is 8. So it's 8 times the square root of 2. How about the square root of 75? Well, it's not a whole number. So we could divide by 2, but it'd be 2 times 37.5. We don't want fractions. It makes things more complicated. If we divide by 3, we get 25. So this is 3, square root of 3 times 25. Now we could go on and express 25 as 5 times 5, but since we're doing a square root and we know that the square root of 25 is 5, we know that this is then the square root of 3 times the square root of 25. And that's 5 times the square root of 3. What about the cube root of 24? Well, 24, if we do prime factorization, it's 2 times 12. That's not particularly helpful. The 12 is 2 times 6. And 6 is 2 times 3. Now, square root of 2 times 2 times 2 is just 2, but I'm going to write this out. And it's the cube root, not the square root. Cube root of this is the cube root of 2 times 2 times 2 multiplied by the cube root of 3. And that's kind of bunched up there and a little hard to read. So I'm going to attempt to redo that, maybe down a little bit lower. Let's just say that that's equal to the cube root two times 2 times 2 multiplied by the cube root of 3, which is cube root of 2 times 2 times 2 is the cube root of 2 cubed, right? And the cube root of 2 cubed is just 2. That's 2 times the cube root of 3. Okay, well, these examples are just a little primer to get you oriented to the idea of roots, radicals, and fractional powers. And you should understand all this. You should maybe go over it, write all these down again, and without the answers, and then see if you can work them out. Okay, maybe 2 days later. Okay. Now I guess we'll keep this board where I can use it again or look at it again. Let's look at an expression like the square root of, well, let's just make it as simple as possible. That's where it sounds a little bit excessive. Let's do the square root of x to the x cubed. Okay. How can we simplify the square root of x cubed? Think about it. Okay, well, you might have seen this and you might not. You've probably seen it if you've had the prerequisite courses. You might not have noticed, okay? I can write that as the square root of squared times x, which is square root of x squared times the square root of x. And the square root of x squared is x square root of x. Now, there's a caveat about this. If x happens to be a negative number, then x cubed is a negative number. Okay, work. Can we say that the square root of x squared is x? Well, the square root of x squared has to be a positive number. And x, if it happens to be a negative number, it doesn't quite work. So you got to be a little careful with this. We'll say more about it. Let's just do this with the square root of a negative number. Let's say we want the square root of negative 49. On a cube, negative 49 wasn't a good choice. Let's just say then we want the square root of negative 64. Well, we can't do it. And I am skipping ahead to something, and I apologize. I'm a little out of sequence in my thinking. Let's say x cubed equals negative 64. Okay, can we solve that? Well, yes, we can. So x is negative 4. And if you cube negative 4, you do get negative 64. Negative 4 times negative 4 is plus 16. Multiply that by negative 4 and you get negative 64. Okay. So a cube can be negative. That puts into perspective something that I'm confusing a little bit here, which is that a square can't be negative. Still, well, that's all there is to it. Since you can't do the square root of a negative, this can't be done. Also, of course, if x is a negative number, x cubed is a negative number, and you would know immediately that you have a square root of a negative number. So what we have to do in this case is we have to say this is only true if x is greater than or equal to 0. If x is negative, doesn't work. Now x cubed equals negative 64, that works. Okay. So let's say we've got something like the cube root of negative 16. And we do this. Well, the cube root of negative 16 is the cube root of well, prime factorization of 16 is 2 times 2 times 2 times 2. That equals the cube root of negative 2 times 2 times 2 times 2. Which is a cube root of negative 2 times 2 times 2 multiplied by the cube root of 2 and the cube root of negative 2 times 2 times 2. I'll even get a little bit more detailed here and write this. Well, that's a cube root of negative of 2 cubed times the cube root of 2. Since a cube can be negative, I'm going to be just a little more formal about this. I don't want to wave my hands over it. Multiply, we can express negative 2 cubed, negative of 2 cubed is negative 1 times 2 cubed. To have cube root of negative 1 times the cube root of 2 cubed times the cube root of 2. And the cube root of negative 1 is negative 1, since negative 1 cubed is negative 1. Negative 1 times negative 1 gives you 1. Multiply by negative 1, you get 1. So this is negative 1 times the cube root of 2 cubed times the cube root of 2, or just negative 2 times the cube root of 2. So if you got odd powers, really the better way to have done this would have been to write it like this. Just start the cube root of negative 16 is a cube root of negative 1 times the cube root of 16, which equals negative 1 times the cube root of 16, which is negative 1 times the cube root of the prime factorization, which is negative 1 times the cube root of 2 times 2 times 2 times the cube root of 2, which is negative 1 times 2 times the cube root of 2, which is negative 2 cube root of 2. Okay, there's not really a big advantage in factoring out the negative 1 here, but might be worth doing. Now, to do the cube root of negative 16 is fairly straightforward. In general, if you've got a bigger number, you're going to want to do a prime factorization and look for cubes within the prime factorization. Now, let's say we've got, we'll do a cube root of 16 x to the 7th. Now, is there a perfect cube that divides into 16? Well, yeah, of course you could do the prime factorization just like we've done here. You see you're going to get a string of 3 2s and another 2. You're going to get a string of 4 2s when you do prime factorization of 16. If you visualize that, you can see that that 16 is 2 cubed times 2. Okay, so when we do the cube root of 2 cubed, we're just going to get a 2. What about the cube root of x to the 7th? Well, x to the 7th is x to the 6th times x. X to the 6th, cube root of x to the 6th is just x to the 6th to the 1/3 power. 6 times 1/3 is 2. Or you could just say x to the 6th is x cubed times x cubed. Whichever way you see it, this comes out the cube root of 2 cubed times the cube root of x to the 6th times the cube root of 2x. Cube root of 2 cubed is 2. The cube root of x to the 6th is x squared. And here you have the cube root of 2x. I'm going to pause for a minute. Okay. Hopefully have the basic idea. Let's do another example. Let's do the 5th root of 480 x to the 7th, y to the 23rd, z to the 4th. Efficient way to do this is to write the 5th root of 480 times the 5th root of x to the 7th times the 5th root of y to the 23rd times the 5th root of z to the 4th. 480, well, if we divide by 2, we get 240. I'll just do the prime factorization of 480 over here, because I'll lose track of all the 2's and 4's and everything. Get the wrong number. So we divide 480 by 2, we get 240. Divide that by 2, we get 120. Divide that by 2, we get 60. Divide that by 2, we get 30. Divide that by 2, we get 15. Divide that by 3, we get 5. Again, I'm dividing by the smallest possible prime number each time. So this is the 5th root of 2 to the 1, 2, 3, 4, 5. And times 3 times 5. Now, the 5th root of x to the 7th can be written as the 5th root of, and let me separate that a little better. The 5th root of x to the 5th times x squared. And then the 5th root of y to the 23rd is the 5th root of y to the 20th times y to the 3rd. And the 5th root of z to the 4th is just the 5th root of z to the 4th, because we don't have any 5th powers within z to the 4th. Now, why do I write it this way? Let's look at the y to the 23rd. 20 is a multiple of 5. Okay, so y to the 20th will have y to the 5th inside of it 4 times. Y to the 5th to the 4th power is 20. Okay, x to the seventh contains x to the fifth, obviously, and also it needs an x squared so that the exponent comes out equal to x to the seventh. Okay, well, what we get out of this is the fifth root of 2 to the fifth times the fifth root of 3 times the fifth root of 5 times the fifth root of x to the fifth times the fifth root. Better put some parentheses in here. These 5s are going to get confused. Fifth root of x squared fifth root of y to the 20th. I've got to wrap this times the fifth root of y cubed times the fifth root of z to the fourth. Okay, well then the fifth root of 2 to the fifth is just 2. The fifth root of 3 is just the fifth root of 3. There are no powers, full numbers inside of 3. So I'm going to write that fifth root of 3 over here because I want all the fifth roots to be to the right of the numbers that we get. Then we have the fifth root of 5. Well, we can do that here. And then we have the fifth root of x to the fifth, and that's just x. The fifth root of x squared, well, that's just the fifth root of x squared, but we'll do a little something with that. Fifth root of y to the 20th. How many y to the fifths do we have in y to the 20th? Well, y to the 20th is 5y's times 5y's times 5y's times 5y's. String of 5y's. 4 strings of 5y's, which means it's y to the fifth to the fourth power. So the fifth root of y to the 20th is y to the fourth. And then we have the fifth root of y cubed. And fifth root of c to the fourth. I think most of these are pretty clear, but let's make sure. Okay. This tells us that we have 2xy to the fourth. Now we've got a product of all these fifth roots, and there's no reason to write that many fifth roots. We can just say we have the fifth root of z to the 4 times y cubed times x squared times 3 times 5. And of course, 3 times 5 is 15. So ultimately, we could write this as 2xy to the fourth times the fifth root, 5 is getting harder to read, of z to the fourth, y to the third, x to the second. Oh, okay, let me rewrite that whole thing. That 5 and the fifth root came out bad. I've got other stuff a little bit out of order. Okay, so let's try it again. Give myself plenty of room to write a 5 for the fifth root. And then 3 times 5 is 15. And usually we put the numbers before the variables in a string and in a product. So we got 15. And then usually x, y, z in alphabetical order. So we write x squared, y cubed, z to the fourth. Now this ought to be equivalent to this. If we take the fifth power of this, we should get what's inside here. I'm not going to do that, but it would be a good exercise. And if you find that it doesn't work out, let me know. It could be I made a mistake, but I don't think so. Because when I look at this, I see that 32 is a factor of 480. It's 32 times 15, and 32 is the fifth power of 2. So I get the 32. I get the 2 and the 15 under the radical immediately. X to the seventh is x to the fifth times x squared. So there's the fifth root of x to the fifth, just x. You got x squared. Y to the 23rd is y to the 20th times y to the third. And the fifth root of y to the 20th was y to the fourth. There's the y to the fourth. And there's the y cubed under the radical. And z to the fourth doesn't have a fifth power within it. So it just goes here. So I'm pretty sure that's right. And then if we cube all this and do the arithmetic correctly, we will get this. I've double checked. I'm 99% sure this is correct, but I won't be totally sure unless I actually cube this and get back to this. And that's just the spirit of checking and making sure that you've got it right. Okay. And one more blurb for checking: gives you immediate feedback if you're not doing it right. If you just write down what you think is an answer and it's wrong, you fail to learn much. If you write it out, check it and find that it's wrong, you've learned something, that you did something wrong. And if you then go back and figure out what you did wrong, then you've really learned something. And that's the ideal case. Okay, well, good luck. This should not be an overly difficult assignment because we've covered the rules of exponents earlier in the course.